In this video, I'm going to discuss about the limit comparison test. Let's consider two sequences, an and bn, both positive, meaning an is greater than 0 and bn is greater than 0 for all subscripts n, and this n coming from the set of natural numbers 1, 2, 3, all the way up to infinity. Now, if it is also true that limit n approaches infinity, an over bn is equal to some number c, which is positive, okay? In that case, both the series an and bn are going to converge, or both are going to diverge. So if an converges, bn will converge. If an diverges, bn will diverge as well. It cannot be crisscrossing, meaning an converges, bn diverges, or vice versa. Let's do an example that will help you understand things better. So let's consider this example where I have a series summation n is equal to 0 to infinity 1 over, let's say, 3 to the power n plus 5. I just made it up. Let's call my an to be here 1 over 3 to the power n plus 5, okay? And let's call another sequence bn, okay? Bn to be 1 over 3 to the power n, and the corresponding series is going to be summation n is equal to 0 to infinity 1 over 3 to the power n. Now let's go ahead and take the limit of these an and bn, okay? So limit n approaches infinity, an over bn is equal to 1 divided by 3 to the power n plus 5, all of it divided by actual limit n approaches infinity 1 over 3 to the power n, okay? So that is gonna give me limit n approaches infinity, okay, 3 to the power n over 3 to the power n plus 5. Now to simplify this, we can just go ahead and divide both the numerator and the denominator by 3 to the power n. So let's divide it by 3 to the power n. So that's going to give me limit n approaches infinity, 3 to the power n divided by 3 to the power n. In the numerator is going to just give me 1 divided by, in the denominator, if you distribute the 3 to the power n, is going to give you 1 plus 5 divided by 3 to the power n. Now, as you can see, as n approaches towards infinity, what happens to 5 over 3 to the power n? That's going to go to 0, right? So this ratio becomes just 1, right? So this ratio is 1. So limit n approaches infinity, an over bn is actually 1. But we know that the series bn, okay, bn, this one converges. So it must be the case that this series also converge. This one, summation n is equal to 0 to infinity, it converges as well. Let's give you another example, which will be slightly different. This one was a very, very simple example. So this is also very simple. So let's say summation 1 over e to the power n minus n, okay? Let's make n go from 0 to infinity. I think we'll be okay if we do 0 to infinity. Oops, this is infinity. So let's call this my summation an. N goes from 0 to infinity, and an is gonna be 1 over e to the power n minus n. Now our question is, does this series converge? So this is my an. Now I'm gonna find the corresponding bn, which is gonna be 1 over e to the power n. So this is something you have to make an assumption of, right? Bn is equal to 1 over e to the power n, and summation bn n is equal to 0 to infinity, okay, 1 over e to the power n, of course it converges, right? We know that because it is 1 over e, absolute value of it is less than 1, right? Okay, so now let's get the limit for this. Limit n approaches infinity, an over bn. So my an is 1 divided by e to the power n minus n. My bn is 1 divided by e to the power n. Limit n approaches infinity. All right. Now, if I simplify it, it gives me limit n approaches infinity, e to the power n over e to the power n minus n. Now I could divide both the numerator and the denominator by e to the power n, right? That's gonna give me 1 on the top, and on the bottom I'm gonna get 1 minus n over e to the power n. Now we could use the properties of limit and that kind of break it down. As we can see, only thing that's going to be dependent on the limit n approaches infinity is this n to the power n divided by e to the power n, right? So limit n approaches infinity, what happens to this guy? I want to find that behavior. So both goes to infinity, but as we know from our experience that e to the power n goes towards infinity faster than n does. So in the long run, the denominator e to the power n is probably going to dominate and bring the entire term down to 0. But we could use the L'Hopital's rule, limit n approaches infinity. That's going to give you 1 over e to the power n. As n approaches infinity, this is equal to 0 really. So this limit goes to 0. So which tells me that this limit goes to 0. In essence, the ratio goes to 1. So limit n approaches infinity, an over bn is equal to 1. Since 1 over e to the power n, since bn converges, it must be the case that summation an also converges, or this summation n is equal to 0 to infinity 1 over e to the power n minus n, it converges as well. So that's what it entails to apply the limit comparison test. So once again, let me go ahead and summarize what I just talked about. So the limit comparison test, we have two sequences, an and bn, both positive, meaning an greater than 0, bn greater than 0 for all natural numbers n as a subscript. So if limit n approaches infinity, an over bn is equal to c, some constant, positive constant, then either both the series an and bn converge or both of them diverge. That's what it means. It cannot be that one converges, other diverges, or vice versa. And I have given you two examples, very, very simple examples of how to apply this limit comparison test to solve these simple problems. Okay, and that should be it. I hope that this discussion was helpful. Thank you very much.